Welcome back to another episode of the Anchor Academy. Today we'll be looking at flute and OD polish grinding on carbide cutting tools and demonstrating how to polish these tools on an Anchor tool and cutter grinder. The difference between an average cut and a perfect cut often comes down to the edge quality and surface finish of the cutting tool. That's where OD and flute polish grinding comes in. Polish grinding enhances the cutting tool performance by refining the surface finish. This reduces friction and improves chip evacuation. This means less heat, a longer tool life, and a better finish on the workpiece. The reduction in heat and friction allows for higher cutting speeds and feed rates without shortening the life of the cutting tool. Polishing also reduces the built-up edge effect, where the workpiece material welds itself to the cutting tool, causing poor cuts and wearing. Let's take a look at how to configure the polish grinding operations in iGrind. You can see here we have the original end mill before any polishing operations are added. If we take a look at the flute from solid operation, we've got inputs to control the major flute features like hook angle and core diameter. We've also got our grinding wheel selection where we've selected our 1A1 wheel to remove most of the stock, leaving a small amount for polishing. From the Add Operation box, we'll add a flute polish operation to our list. After adding the operation, we'll firstly assign the polish grinding wheel to the operation, and we'll set the cutting speed for the wheel at 25 meters a second. We can see in the cross-section dialog that the flute shape we're generating with the 1v1 polishing wheel is different to the flute shape ground by our 1A1 when we initially grind the flute. We can also see this in the 3D simulation. To allow us to polish the entire flute surface, we're going to edit the wheel clearance angle to achieve a similar shape to what we've got with the 1A1 wheel. We're also going to add a small amount of Z in feed, so we're removing 25 microns of stock with the polishing wheel towards the flute face and towards the tool center. Now you can see from the color mapping in the simulation that the flute polish is going over the entirety of the rough flute surface. For the washout section of the flute, what we can do to avoid putting a heavy load on the polishing wheel is to extend the washout in the flute from solid operation. This just saves our polishing wheel from experiencing any higher grinding load and wearing prematurely. Lastly, we'll set the grinding parameters for our flute polish operation. To add polishing to the outside diameter of the cutter, we'll enter the OD finish operation and add spark out passes to both the first and second reliefs. We can select the polish grinding cup wheel for both relief spark out passes. Importantly, if we add an infeed amount to the spark out passes, the final diameter size we've programmed in the common parameters will be respected and maintained. So we'll add an infeed of 15 microns for the spark out. Today we'll be working on the TX Linear, although this application is also suitable for other tool and cutter grinders such as the FX and MX series machines. The TX Linear features a 2-station wheel changer, which we have set up with some nice grinding wheels from Tyrolit. The work holding on the machine is the Anker Premier Plus collet adapter with a B3245 Schaublin collet. The cutter we'll be grinding is a 12mm diameter 3-flute carbide end mill, something that you might use for machining aluminium. For polish grinding carbide tools, resin bonded diamond grinding wheels are the best choice. Resin bonds provide a soft, controlled grind, reducing surface roughness and preventing microchipping on the cutting edge. The grinding wheels should have small diamond grits from D5 to D20. We'll be using the Tyrolit XP-F series grinding wheels with grit size D15. These wheels have a resin bond system with good wear resistance and shape retention. The wheels can remove up to 0.2mm depth of cut. Today we'll be polishing around 50 microns of stock from the cutter. The main stock removal is being done by the first wheel pack. To measure the surface of the tool, we'll jump onto the Alicona 3D measuring machine. We'll be able to scan the surface and measure the roughness in the flute. We can see that we've achieved just over 0.1 micron RA, which is looking pretty good. So to wrap things up, polished carbide tools offer greater performance to the end user. With a simple setup on an Anker tool and cutter grinder, we can easily achieve a high quality surface with consistent results. That's our episode for today. Thanks for watching. For more e-learning and training, please head to ankerclub.com.